let's get something straight right at the top. You've probably seen those wild headlines screaming that NASA has found proof of a parallel universe. So has NASA officially warned the world that we have a cosmic twin? The short answer is no, but the real story is actually far more interesting. The reason those headlines even exist is because humanity's greatest eye on the cosmos, the James Webb Space Telescope, is sending back data that has scientists genuinely stumped. It's been gazing back to the dawn of time and has found things that, according to our current rulebook for the universe, simply shouldn't be there. The discoveries are so profound, so challenging, that they're forcing some of the world's top scientists to consider ideas that sound like they were ripped from the pages of science fiction. One of the most mind-bending of these ideas is that our universe isn't alone, that a parallel mirror cosmos has existed alongside ours from the very beginning, and that we may have just seen its first ghostly fingerprints on our reality before we get to the part where the rulebook gets torn to shreds. We need to understand the book itself. It's called the Landesi-DM model. For decades, it's been the standard model of cosmology. Our official biography of the universe, the story, starts 13.8 billion years ago with the Big Bang. From an unimaginable point of heat and density, everything erupted. For about 380,000 years, the universe was a hot, glowing fog of plasma. Then, as it cooled, atoms formed and light broke free for the first time. We can still see that first light today as a faint glow in all directions, known as the cosmic microwave. Background: according to this model, the next few 100 million years, the cosmic dark ages, should have been pretty quiet. Gravity was patiently pulling together the first clumps of matter, building small, simple starter galaxies. The plan was a slow, bottom-up assembly line. Little galaxies would merge over billions of years to create the grand spirals like our own Milky Way that we see today. This model also tells us what the universe is made of, and it's a bit humbling. Everything you can see and touch, stars, planets, us, makes up a measly 5% of the cosmos. About 27% is an invisible substance called cold dark matter. We can't see it, but we can detect its gravity, which acts as the invisible scaffolding for galaxies. The other 68% is dark energy, a mysterious force pushing the universe to expand faster and faster. This recipe, the Landesi-DM model, has been incredibly successful. It predicted the cosmic microwave background and the large-scale structure of the universe with stunning accuracy. It's the bedrock of modern cosmology. And that's exactly why the new data from Webb is so electrifying, because it suggests that in the very first chapter of the universe's story, something is very, very different from what we expected. The James Webb Space Telescope isn't just a bigger Hubble. It's a time machine built to see the ancient infrared light from the dawn of creation, and what it's finding is, well, weird. Remember those small, simple toddler galaxies our models predicted for the early universe? Webb found monsters instead. It has spotted galaxies that are shockingly massive and startlingly mature just a few 100 million years after the Big Bang. These galaxies are already packed with hundreds of millions of stars, far more than should have been able to form so quickly. It's like finding a fully grown oak tree where you expected to see a handful of acorns just starting to sprout. It challenges the known rules of growth, and it's not just one or two. Webb is finding these impossibly early galaxies all over the place. They're not only big, but they're also filled with heavier elements like carbon and oxygen. Since those elements are cooked up inside stars, finding them in such abundance suggests multiple generations of stars had already lived and died, a process that should have taken way longer. It's like the universe had a secret head start then. There's a problem that's been brewing for years, known as the Hubble tension. It's a cosmic whodunit. When scientists use data from the early universe, the cosmic microwave background, to calculate how fast the universe should be expanding today, they get one number. But when they measure the expansion directly by looking at stars in the nearby universe, they get a different, faster number. For years, everyone hoped it was just a measurement error. But with more precise data from Webb, the discrepancy has only gotten stronger. It's real, our cosmic GPS seems to be missing something. Finally, there's a much more speculative clue. In a perfectly uniform Big Bang, you'd expect galaxies to spin in random directions of 50/50ths split between clockwise and counterclockwise. Some controversial analyses have hinted at a potential imbalance of preferred spin direction on a cosmic scale. Now, this idea is far from mainstream and is hotly debated, but if it were ever proven true, it would be staggering. It would imply the universe itself has a hidden axis of feature completely unaccounted for in our standard model. So, what do you do when your observations keep clashing with your best theory? You can try to patch the theory, or you can ask a much bolder question: what if we're only seeing half the picture? This is where some physicists are venturing with an idea that sounds wild but could potentially explain these cosmic puzzles. What if our universe has an invisible twin mirror universe? This specific idea, called the CPT-symmetric universe, was proposed by physicists like Latham Boyle and Neil Turok. They suggest that the Big Bang created not one but two universes. It created our universe and an anti-universe that is its perfect mirror image, expanding backward in time from the Big Bang. Sounds crazy, right? But here's where it gets interesting. This isn't just a cool concept. Its proponents argue it could solve some of physics' biggest headaches. First, dark matter. What if it isn't a mysterious particle in our universe at all? In this model, the anti-universe is filled with its own particles. We could never touch or see them, but we would feel their gravity leaking across the cosmic divide. What we call dark matter might just be the gravitational echo of a universe next door. This could also help with the Hubble tension. The extra gravitational pull from a neighboring cosmos could be subtly tweaking the expansion rate of our own universe, explaining why our local measurements are faster than predictions from the early universe. And what about Webb's massive early galaxies? If there's a huge reservoir of gravity from a mirror universe, it would act like a cosmic steroid, dramatically speeding up structure formation. It would pull matter together faster, allowing galaxies to get bigger quicker. Those impossible galaxies suddenly become possible. We are standing on the edge of a revolution in how we see everything. The old cosmic map is being redrawn in real time. Let's be clear, this is still a speculative hypothesis, but if a theory like this one were ever proven true, the consequences would be staggering. It would mean our entire understanding of reality has been fundamentally incomplete. We've been looking at the sky thinking we were seeing the whole show, when we were only ever seeing one side of the coin. Our entire origin story would change. The Big Bang wasn't just the beginning, it was a moment of creation for a cosmic pair, born together but forever separated. It forces us to ask incredible questions. If gravity can cross the divide, what else can? The theory suggests nothing, but the question itself redefines the limits of what's possible. This opens the door to other wild ideas that have long been on the scientific fringe, like black hole cosmology. This theory suggests our entire universe might exist inside a black hole from a larger parent universe. While still highly speculative, some of the strange data points, like the faint possibility of a cosmic spin, could be seen. Faint whispers of support for such a radical model. A universe born from a spinning black hole might just inherit that spin. Perhaps the most profound implication is philosophical. It suggests our universe isn't random, but part of a balanced, symmetrical whole. But it also means we're inextricably linked to a shadow world. We can never, ever visit a world where, from their perspective, we are the anti-universe. It's a humbling thought that suggests the cosmos is not just stranger than we imagine, but stranger than we can imagine. So, to circle back to the beginning, has NASA confirmed a mirror universe? Absolutely not. There has been no official declaration and no proof has been found. What is happening is the scientific process playing out on a grand scale. The James Webb Space Telescope is working better than we could have ever dreamed. It's pushing our theories to their breaking point, and they are starting to fray. The anomalies, the unexpectedly massive galaxies, and the persistent Hubble tension are very real. The data is solid. The Lambda EDM model, the bedrock of cosmology, for a generation is facing its greatest challenge yet. In response, brilliant scientists are proposing bold, provocative, and sometimes wild ideas to try to make sense of it all. The mirror universe hypothesis is one of the most elegant and creative of these proposals. It is not proven fact, it is a speculative idea that is now fueling intense debate and research. What's certain is that we have entered a golden age of cosmology. Webb has given us a new window to the dawn of time, and the view is shaking of everything we thought we knew. The old maps are being torn up, and the race is on to draw new ones. We're living through a scientific revolution, and we're all watching it unfold together.